number. If you were to measure a piece of hair is about 2.5 thousandths in diameter. So we just held a tolerance less than half a hair. So if you want to call splitting hairs part of machining, that's exactly what we do. Okay, so we've got our part cut to length. I took the liberty of doing a few things in advance. We're going to put a series of holes in this block every inch. So I put a little layout ink on there with a, I think you can kind of see the layout there. I took one of those big magic markers and put some red ink on there, and I took it over to a height gauge and I scribed my lines of where my first hole is going to be. Basically, you could lay out all your holes, all your locations, but these are nominal 1 inch apart locations. So I'm going to put this piece in there that I've got the layout on. I only machined one end on it, but we can finish the length after the other work is done. Want to make sure that you've got a clean surface there. I've got parallels I'm sliding on here. I'm going to start this, since we're only going to do one block, I'm going to start this farther back in the vise because I want to find out where the center of my block is. Our holes are going to be dead center in the 1 inch, so I'm going to make sure I'm dead center on the part. And then we've got to locate off the end, put our first hole in there. The parallels in there, if you can see, are on both sides of the vise, but they create a gap in between, so all our drills that we drill into the block won't hit the parallels. They'll have a place to go clear through. So that's what the parallels do. They raise the part up, and then you can see where your part is at. You can drill through and not have to worry about hitting anything. But we're not going to use this cutter for it. This cutter here is a 4-flute end mill. End mill is looks kind of like a drill, but it's stout and rigid. It won't flex. A drill is long and skinny, and it'll float around. Okay, this particular machine has a power drawbar on it. I'm going to take this cutter out. Out she comes. This particular machine has an R8 spindle on it. You can kind of see what this looks like here. It's got a taper on there. If we put a collet in there that grabs an end mill, the collet matches up with that. When you pull the drawbar tight, it grabs the cutter shank. Okay. We didn't need that on this particular application here, but we've got the same thing. The shank is on this chuck, and we're going to use this chuck here. I should tell you, this collet here has a keyway, or this collet shape has a keyway in it, and in the spindle of the machine there's a little key sticks out. So you slide this thing in, turn it until it allows that collet to slide up into the spindle, and that will protect your collet when you've got a heavy cut that you're making or you're drilling a hole, that the collet doesn't spin inside your spindle. Okay, I've got it lined up there. I can't rotate it. I'm going to pull it in, and she's good and tight in there now. I dropped my chuck key. Okay, we've got the layout line on here, so you saw that a minute ago. I'm going to take this edge finder, it's called, small device here. It's got a spring-loaded tip on it. If you can see this, it wiggles on there. I'm going to put this in the chuck, and we're going to pick up the edge of this workpiece. Now, you might not have an edge finder like this. I'm going to turn this thing on, and if you can see it, it's wobbling around there. Okay, that's by design. We're going to bring this thing over here, and I'm going to drop this down here so my edge finder is right next to my piece. I'm going to try to bring the camera over here now so you can see what's going on. Somehow, I hope. Let's see where we're at. Okay, I'm going to set it here like this. This is a high-tech operation in the media way we're doing this, but I'm not very good at that, but I'll be able to show you how to machine. You won't have to worry about doing a picture. Okay, I'm going to move the block towards the spindle. You can see all of a sudden it started running nice and true. I bring it in, and I move it in until it just jumped off. Okay, that means that my location is within 1/1000th of an inch, as that thing jumps off, of the edge of the part where it's touching. But now we've got to measure the diameter of this edge finder. It's 200,000ths of an inch in diameter. Okay, so that means that with this being 200,000ths in diameter, means that the center of our spindle is 100,000ths off the edge of the part. Okay, so I'm going to go over here into the readout, if you can see the numbers here, and I'm going to do that's a y-axis. I'm going to hit the y-axis. I'm going to put 0.1, enter. So I'm 100,000ths off of there, and I'm going to turn this edge of this part down to 0. If you can see on the readout, it's going down to 0. When I get to 0, my spindle will be exactly on the edge of the part. Okay? Okay, I'm right on 0. You might have noticed that last digit there was a 5. That's a 1/1000th increment. This here is 1.5065. That last digit there means a 1/1000th. The machine doesn't read any smaller than that, resolution-wise. Don't worry about all that. You're mainly here to see where our hole's going to be. Okay, so we're at Y0. Our dimension, our line of holes, is going to be at a 1/2 inch. So we're going to move this into 0.500. A 1/2 inch is 0.500. 100, 200, 300, 400, 500. Okay, Y is on 500. Alright, now we're going to do the same thing on the end of the piece. We're going to bring this guy down here. We're going to do the same thing. We're going to find the edge of the piece. You can see the spindle. Oh, there we are. You see the spindle turning. We're going to move this in until the edge finder it's wobbling right now, but as I touch and make contact, it's going to come in running through her with the shank. Get a little closer, get a little closer. As soon as that thing jumps to the side, okay, that means I'm within 1,000th of being location-wise. Okay, so we're going to go back up here to the readout here, and I'm going to punch in the x-axis is 0.1. I'm going to enter that. Now if I move this, oops, went the wrong way. So I'm going to go to 200. That's the same difference as moving it 100,000ths. I had to get it right to the number there. Okay. So now I know where I'm at. I'm at the end of the workpiece. Oops. End of the workpiece, and I'm going to set my readout at 0 on X. X 0.0 set. Okay, so I got my spindle even with the end of the part. I'm in the center of the piece. Now we've got to move over 100,000ths, or I'm sorry, 1 inch. 2, 4, 6, 8. We're getting up right to 1 inch. Oh, one passed. Right on 1 inch. Okay, so our first hole location is going to be right where our spindle is now. So I'm going to take that edge finder out of there and put in a different tool. This tool here is a spotting tool. It will go down and start a hole right where we want to put all of our holes. But I've got my layout line in there, so we want to see if that spotting tool goes right where my layout line is here. Let's do another high-tech view of this thing here, if we can see it. Let's see where my camera angle is. This is I apologize for the bad video here. I'm gonna have to do something about that. Okay, our hole is right on the nose for the layout line that we had, if you can see that. This is not going to be a very good video, so I may have to redo this again. Okay, now if we were off, we'd see it. If it was off any amount, we'd see it. We know we're right on our dimension that we got to be. I'm going to lower this table here because we got some long tools that we're going to be putting in this chuck here. So I'm going to drop the table down. Here's I want to get this over here. Here's a crank on the front of the table. It drops everything down because we got some long tools that we've got to run in there to do our holes. That might suffice, but maybe not. I'm going to put this back where it was. I've got this camera attached to a nice big block here that I'm able to move around here a little bit. I apologize if it's not good video here, but you see what the point is, that I've got all these holes and layout lines and everything done. I'm going to put this in the other way. I didn't like the quality of the hole that I got, so I'm going to spot this a little bit different. Okay, now, like I said, every hole is 1 inch apart. So we got our first hole at 1 inch. It's right on the layout lines. It's dead center in those 2 coordinates there. I'm going to drill it a little bit better. That'll give our drilling tools a better spot to start. Okay, I'm going to move another 1 inch. That'll be 2 inches where we go to. I just need a little starting spot for the drill. 2, 4, 6, 8, 10. Most tables on milling machines move 200 thousandths for every time you turn the handle. Okay? 200 thousandths. So you might be hearing me counting 2, 4, 6, 8, 10. So I'm at 3 inches. 2, 4, 6, 8, 10. I'm going fast. Come back. Right at 4 inches, exactly 4.000. We're getting our starting spot marked here. 2, 4, 6, 8, and this is 5 inches where this one's going to be. I don't know if you can see how I'm moving the handle, but I always keep the play on the handle going clockwise on this end. If you have a manual machine and it doesn't have a CNC control on it, you've got a big long screw and a bronze nut in there, and if that's worn out, you're going to have some slop in the screw, so your table may not move accurately. The digital readout that's on there will tell you where you're at. You don't have to worry about that, but if you have an older machine that does not have a readout on it, always keep the play of the handle going clockwise from whichever end you're working on. This machine's only got a handle on one end. Older machines or other machines, non-CNC, have handles on both ends. So depending on where you're at, always go to the same rotation for your handle so all the play in the screw is the same. I've been kind of talking here, but I didn't go down the list by steps here. Our first step was getting the sketch in the front and having some safety glasses on. That's a critical thing. The second step is selecting the material, which I've already pulled that out. Third step is how you saw and cut your raw material to length. The fourth step is preparing your milling machine. We look to see that the vise was straight on the table, because the table has a x-axis and a y-axis, and they are 90 degrees to each other. There's a few things that you have to trust on the machine itself. That is that the axes are 90 degrees apart, not 89.5 or 90.5. They got to be 90 degrees. So you can trust that that's what the case is. So you've got to prepare your milling machine, get your vise set on there, make sure it's straight. uh,